Moving on to the next question over here. A geometric progression is such that its sums to 4 terms is 17 times its sum to 2 terms. It is given that the common ratio of this geometric progression is positive and not equals to 1. Find the common ratio of this geometric progression. So what you need to do is you need to be able to use the formulas and identify what these are, all right? The sum to 4 terms. So we are definitely using the sum formula over here. The sum of 4 terms, which is a bracket 1 minus r to the power of 4 over 1 minus r, is 17 times its sum to 2 terms. So it's the same right now. A bracket 1 minus r square over 1 minus r. Okay, this is the sum formulas for the geometric progression here. What you can do is when making the comparison, you can either bring this denominator upwards and cancel each other, okay? Or you just know that you can ignore this bottom denominator here since they are the same value, all right? And equate this into this. A 1 minus r to the power of 4 equals to a 1 minus r square. So in what you can do next is you can actually cancel the a's as well. A divided by a is 1, right? So you will cancel the a as well, and then you will only be left with 1 minus r to the power of 4 equals to 1 minus r to the power of 2, and 17 times of that. So you have to multiply 17 at the front. Writing down the equation now, 1 minus r to the power of 4 is equals to 17 minus 17r squared. From here, you guys need some practice, but you should be able to see that it's actually a quadratic equation. When you group it all up, negative r squared plus 17r, r to the power of 4, negative r to the power of 4 plus 17r squared, bring this over to the left, and then 1 minus 17, you get minus 16 equals to 0. To make it a quadratic equation, all you have to do is let r to the power of 2 equals to y, for example. Then over here you have negative y squared plus 17y minus 16 equals to 0. Solve for y. Y is actually equals to, typing into your calculator, you should have gotten the value of 16 and or y equals to 1. Okay. After that, change y back into r squared. R squared is equals to 16 or r squared equals to 1. We do not use this answer here because, as the question states, where this geometric progression is positive and not equals to 1, the common ratio does not equals to 1. So we can ignore this answer and just solve for this. R is equals to square root of 16, which is just equals to 4. Then you would have found the common ratio, which is 4. Right? Now, next question. Given that the sixth term of the geometric progression is 64, find the first term. If the sixth term is 64, so we're going to use this formula here. 64 is equals to a bracket r, which is right now 4 to the power of 6 minus 1, because it's the sixth term, right? Okay, so 64 is actually equals to 64 over 4 to the power of 5 is actually equals to a. And in this case here, a, type that into your calculator, would equals to 1 over 16. Okay, a is equal to 1 over 16, and that will be your answer, finding the first term. Last part, explain why this geometric progression does not have a sum to infinity. Now, to explain this question here, all you have to see is this formula over here, all right? Where in the actual question papers, they actually give you more information where r is actually less than 1, okay? It can only be sum to infinity if r is less than 1. If it's not, you will never get an ending to it, all right? So in this case of ours, r is actually equals to 4. So to explain why, we must say that the value of r here is more than 1. And that's it for your 1 mark question. Nothing too complicated. Don't complicate it. Okay. And now we have your last question here. A geometric progression has a first term of 3, a second term of 2.5. For this progression, find the sum of the first 8 terms. So writing this down first, the first term a is equals to 3, and then in the geometric progression, AR is equals to 2.4. So in this case, what we can do is we can actually find the value for R first. R is actually basically, this is term 1 and this is term 2. Term 2 over term 1, 2.4 over 3, you would have gotten R is equals to 4 over 5. Okay. Finding the sum of the first 8 terms using this formula here. This other sum formula is only for sum to infinity, okay? So don't use that one. Using the formula, a is 3, bracket 1 minus 4 over 5. 4 over 5, and to the power of 8, okay? 4 over 5 to the power of 8 over 1 minus 4 over 5, okay? And this is your sum of the 8 term formula. What you're going to do is you're going to type this into the calculator, and you should have gotten the answer of 12.5. Okay, that's your sum for your geometric progression. Next, the sum to infinity. As you can see, what I explained earlier, when the r value is less than 1, you will get a sum to infinity. Okay, so the sum to infinity here is very straightforward. Just have to put it into the formula. 3 over 1 minus 4 over 5. This is your sum to infinity formula, which will therefore equals to 15. Simple. Right? And the last part here, the least number of terms for which the sum is greater than 95% of the sum to infinity. So first thing we need to do is find what's the value of 95% of the sum to infinity. 0.95 times by 15, you would have gotten, what value is this? 0.95 times 15, 14.25. 0.25, okay? You want to have the least number of terms for which the sum is greater than 95%. So using this formula here, okay? S of n, which the number of terms we are looking for, or maybe I should start with this side of the formula. A is 3, 1 minus 4 over 5n over 1 minus 4 over 5, okay? This should be greater than 14.25. Now all we have to do is solve for n here. 14.25 times 0.2 at the bottom here. 14.25 times 0.2, 2.85 is less than 3 bracket 1 minus 4 over 5 to the power of n. Okay, then 2.85 divided by 3, 0.95 is less than 1 minus 4 over 5 to the power of n. Bring 1 over, negative 0.05 is less than negative 4 over 5n. And lastly, log both sides of the equation, or you can just change them into their positive values first. 4 over 5n is greater than 0.05. Okay, then log both sides. Basically over here you have n log 4 over 5, which is 0.8, is greater than log 0.05. Okay, type this, to find n, it's basically just log 0.05 over log 0.8. Type that into the calculator. we would have n needs to be greater than 13.4. In which case, if n has to be greater than 13.4, n has got to be at least 14 for it to be greater than 95% of the sum to infinity. And that is it for this video. Hope this video helped you guys. See you guys in the next video.